These questions are more challenging. They're pretty challenging. I did them. I did them a little bit in a more complex way. There's more than one way to do it, and there's a good way to do it. You could look at this sine 3x thing here. We're supposed to prove that this all equals 2. Now, my first time I looked at this and I went, oh, it's another x, 2x plus x thing. And you can do it that way, but it gets really complicated. When you're looking at a thing like this, it's really just about combining fractions. You should try that first. If you go sine x times cos x, you get a common denominator and then cross multiply. So you're trying to combine this. You'll get cos x times 3 sine x. You'll get sine x. Hey, that looks like one of our identities. Sine cos minus cos sine. That's the cos of 3x minus x. That's the cos. Sorry, that's the sine. It's not the cos identity. That's the sine identity. It's the sine of 2x. And that's really good because the sine of 2x is 2 sine x cos x. And divided by that sine x and cos x on the bottom there, it all cancels and you just get 2. Now that's pretty tricky. I went the wrong direction and it can get pretty messed up. The next question, maybe it's the same idea. Let's see here. I think it is. In fact, it is for sure. You see, you have a common denominator, so you multiply just like it was numbers, you multiply the two bottom ones together to get the common denominator, and then cross multiply. And what do we get here? We get the cos one. That's sine, cos, cosine, and this one looks like the cos one, where it's the cos of 3x minus x. That's right, the opposite of that plus, which is the cos of 2x. And what's the cos of 2x? It's cos squared minus sine squared. And that's what they've written this in a way of it factored, like the difference of squares. So you know it's cos squared minus sine squared, which really is cos plus sine times cos minus sine. And that equals the right-hand side. And there you go. So you've got yourself an answer.